Will, we have a lot to talk about
We do.
ARM has had some fascinating news over the last month getting into the CPU race yourselves. Share it with the audience for those who may not know. And I'd love to hear some context on why it made sense for you guys as the kind of architects of chips to really get into the business of chips yourselves.
Yeah, so Madison, it's really nice to be here with you. And for those of you who have stayed, I'm really pleased that you're here. It would be a little bit odd if Madison and I were just talking by ourselves. But so the question, why now? Mm-hmm. So if you look at the AI infrastructure that we have today, it is moving to a world where agentic workloads are running continuously. Those workloads need CPUs for reasoning, CPUs that move the data in that infrastructure world, CPUs that are basically continually orchestrating everything that AI infrastructure demand requires. And so I can't think of a better demand. All of that said, as the industry is deploying infrastructure at scale, power is not free. Power is not free. And so you got to think about a world where power is scarce, a world where you need more CPUs. And so from a performant, power-efficient architecture, it plays really well into all the things that ARM is thinking through, all the things that ARM is developing. And so 2 weeks ago, Madison, as you and I were talking about, we unveiled to the world our first AGI chip. And again, it's bearing in mind this insatiable demand for more compute in a continuously running agentic workload environment. We're augmenting the IP business that we have today with compute subsystems. And then on top of that, we've now unveiled a chip to give our partners opportunity and flexibility to deploy the right solutions for their needs.
And what is it about your CPU offerings that allow for better price performance?
That's a great question. And so the ARM CPU, the backbone, I think, for the semiconductor industry, cumulatively now, since the beginning of ARM to today, we've shipped 350 billion cores. And so the key tenet that makes ARM unique is power performance, but also power efficiency. So high performance, power efficiency, encapsulated with a development, software development community that, believe it or not, spans 22 million developers. So you take the ingredients of performance and power efficiency, and within a specific power envelope, for a data center power envelope, we can deliver more performance in that power constraint envelope. And so a chip that offers that is ideal for this agentic workload environment that we're now entering into.
Yeah, and it's fascinating because you hear about like token maxing at some of the major AI labs and hyperscalers, which also to me just sounds like a really hefty amount of CapEx. How do you think about the metric that teams should be using in terms of their approach to tokens? Should it just be use as many as possible, or should it be about price performance and maybe effective and efficient usage?
You've covered it all. So price performance is key. The key measure is performance per watt, and you need to be able to develop your application with those constraints in mind. But more importantly, it's not just performance and power efficiency at the chip level. You got to think about performance and power efficiency and performance per watt at the rack level. Yeah. And so just having a performant, power efficient CPU that doesn't play well with memory, that doesn't play well with a data scale rack is not sufficient. And so the thing about what we're doing, we're developing a chip, but we're doing that with the ecosystem, making sure that we're working with the ODMs, the OEMs, but really targeting this agentic workload, this explosion of more CPUs that's required to bring to life this agentic this agentic sort of era that all of us will benefit from.
And speaking of that ecosystem, how are you thinking about the sort of co-opetition dynamic that you're in, given that some of your customers are also going to be your competitors now that you're in the CPU space?
Yeah, I mean, to be candid, I think that's an old way of thinking about the market dynamics. In a constrained market with X number of users, with known use cases, then perhaps you could say it's competitive. But the reality is the speed of which this agentic AI infrastructure world is moving the opportunities are vast. I don't think any single company can address all the opportunities that they see for themselves, whether it's in the cloud or on-prem. The opportunities are vast. And so what we're doing at Arm, from an IP capability, the platform is either at an IP level, it's at a compute subsystem level. So you take your CPU, you take your GPU, you take the interconnect, you highly optimize all of those components for a given workload and a given application. We're taking those two offerings, IP, compute subsystems, and now we're saying we've also got a chip for you. So you, Mr. Customer, choose the pathway to which you want to engage with Arm. We're comfortable with all three or one, depending on what your economic model is and what you're trying to achieve within the constraint windows that you have to get to market.
Is that sort of the biggest challenge that you hear of from customers? Is it still just about compute and lack of supply, or is there something that has shifted in that conversation over the last couple of months?
Yeah, I mean, performance is always critical.
Yeah.
But performance and power efficiency, I think the world recognizes that if in order to meet the demands and the promise of AI, compute obviously is important. But if the power is not there, then we're not going to meet that demand head on. But rolling out more data centers is not going to happen overnight. Mm-hmm. So in a world where you have more data centers, you still need to use that compute efficiently. Yeah. And so I think that plays really well from an Arm perspective. It's not something that we woke up one day and thought, hey, let's deliver solutions that are performant but also power efficient. It stems from our DNA. In the early days, what we were trying to do is develop CPUs, IP cores that target consumer applications. So PDAs, mobile devices, consumer devices that run off a lithium or coin cell memory device. And so, battery device. And so in that world, our architects and our solutions have that principle, that tenet embedded in how we come to market. So performance, power efficiency. And with all ecosystems, you got to think about software and software developers. And so whether it's in the AI infrastructure cloud business or the consumer business that we have, making sure that we have a rich software development community targeting our platform is really important to us. I think that's what makes Arm unique.
Given the power demand picture that you're painting too, I'm curious how you think that will get paid for. We've heard from the likes of OpenAI's Sam Altman that maybe AI usage is going to be metered and that consumers will end up footing the bill. Curious what you think about that future.
Yeah, I think, again, that's another reality check, right? So I think all of us are thinking about using agents, right? So unlike humans, agents run 24 hours. They don't sleep. So the amount of tokens that are generated or will continue to be generated are going to explode. In a world where you're not paying for those services, you'll go off and generate as many as you can. Mm-hmm. But the reality is that, on my phone today, I can run ChatGPT. It's capped to whatever it is, $20 a month. But that's not realizing the agentic reality that we're looking at. More tokens being generated, more compute being needed. And so in a world where compute and power is metered, you want your solution to be power sensitive, but performance at the same time. Yeah. Again, I think that's what makes the Arm solution really attractive. Unlike an x86 system, we believe for the same power constraint, you can deliver 2x performance. And so if 2x performance at the same power equals an economic benefit, a CapEx benefit, and wins every time.
I imagine that also informs your thinking about AI at the edge as well and how that could be a potential solution.
Yeah, I think, great question. So, I mean, if you think about the reality of what we're doing today, most of the workloads were at one point in the cloud. Mm-hmm. And so in a agentic world, the device that's in my pocket and your pocket is going to be running, it's going to be your agent, right? Mm-hmm. And so that's an example of an edge application. So now just imagine you've invested in your software, in your application that's running in the cloud. Wouldn't it make more sense to be able to take that same software, that same workload that you've optimized for, and run that at the edge? Perhaps the model size is smaller, but the investments that you've made in the cloud are the same investments that you can deploy on the edge.
Yeah.
And so again, that's another benefit from an ARM architecture, from running workloads in the cloud, moving those workloads onto the edge. We believe that's what makes us unique.
And it's interesting because all of the businesses I've interviewed, being here at HumanX, I spoke with an executive at NVIDIA yesterday who told me unequivocally they are spending more money on tokens than human labor right now. And I wonder how long that can last for these AI labs. Do you think that that is a near-term problem that is going to have a longer-term solution with the likes of edge computing or cheaper chips going forward that make costs per token a little bit more accessible?
Yeah, I mean, so look, the reality is the industry has to think about the economics of what we're doing, right? And so I've spent a lot of time talking about how we think about making sure that performance at scale is being delivered with power efficiency at the core of it.
Yeah.
OpenAI talk about the fact that the model that you have today is probably going to be the oldest model that you have. But what we are seeing is specialization in models, right? So models that are running at the edge that become more efficient, smaller in footprint and capacity. But the industry has to think and work together to ensure that we're deploying solutions that are economically sensible, that are still performant, and take into consideration power and the fact that power is a scarcity.
What do you think is the biggest misconception at enterprises right now about AI adoption and what the costs of AI adoption look like?
Yeah, I think until you've actually deployed a solution, enterprises don't fully appreciate the amount of investment that's required.
Yeah.
But here's the benefit that we're seeing. So if I'm in the cloud today,
Yeah.
and I'm running, whether that's AWS Cloud, AWS and Graviton, whether it's Microsoft, whether it's Google, all of those instances are potentially running on ARM, right? The idea that you want to move from a cloud environment to on-prem because security is important, the misconstruction or the misunderstanding is that you can't reuse the investments that you've made in the cloud.
Right.
You can't bring that down to on-prem. You can't bring that down to an edge application. With ARM, you can. And so we're using opportunities like this to make sure that the industry understands the scalability of cloud going down to on-prem and potentially going onto the edge as well.
And since you mentioned security, I am curious about any hardware level features that you all have to address security concerns. Even today, Anthropic announced a model that they were going to release, but it was so powerful, they're only going to work with certain partners to release it, the likes of JP Morgan Chase, for example. How does a move like that in the industry make you think about security level hardware offerings you have to have for enterprises to feel safe?
Yeah, so security has always been at the heart of everything that we do from a consumer application perspective. When you think about what consumers like you and I are doing with our mobile phones, understanding that there's a root of trust for hardware and there's a partition between what the user can access and what the programmer can access has always been important. But I think it becomes even more important in an agentic world, a world where what personal information I'm feeding into that agentic system has got my personal details, not just my banking details. It's got my health information. It's got my family details. It's got potentially information that's close and dear to me. And so as we deploy more of these agents, security, not just at the hardware level, but at the software level, becomes important and becomes even more important than today's systems. And so, yes, performance is important. Yes, power efficiency is important, but security, another tenet that we believe in, is going to be extremely important for our platforms that we deploy, whether it's in chips or in compute subsystems or even at the IP level, Madison.
And given that you are seeing these model releases up close, you're seeing the technology up close, what is it right now that you've seen over the last maybe 3 months that sort of is keeping you up at night, is concerning you about the power of AI right now?
I mean, the demand, honestly, the demand is insatiable. And so when we listen to our partners, they want us to run even faster, right? And so how do we do that? First step is giving partners choices, right? And so we've done that with the AGI chip that we've brought to bear and launched 2 weeks ago. But I think recognizing that use case explosion continues to be dynamic and that partners want us to run very fast.
Yeah.
And so that's what keeps me and the team at Arm awake at night. How
Yeah.
can we go even faster? How can we shorten the development time scale? How can we allow partners to get to market even quicker?
I think there's an idea that businesses might be slower to adopt AI because businesses always move slower than we think. But I've actually heard quite the opposite, that enterprises are being shockingly fast at AI adoption. It sounds like you've seen something similar.
I mean, Arm, we're using AI at scale from engineers that are looking at ways in which they can make the work they do more efficient.
Yeah.
A classic use case is I develop a functional block. I then need to write some documentation and test that block. And so AI can make a difference there. And we've seen that happen at Arms, right?
Yeah.
So making engineers more efficient, helping even my own support organization. How can we help our partners even quicker and much faster? So this efficiency story that behind AI is real. We're seeing it at Arm. And I think other companies in semiconductors are also seeing the same benefit.
Yeah. And what is the single biggest thing that you think enterprises, people in the room, should take back to their jobs and their day-to-day in terms of making sure that they are proving out an AI ROI case as well?
Yeah, so I mean, I think I've made it quite clear that
Yeah.
the importance of power, right?
Yeah.
It's not free. And so you want to deploy solutions, compute solutions, that at the heart of the solution is this idea of high performance, power efficiency. And then just, playing the efficiency game. AI tools are real, and AI tools can make enterprises more efficient. And so as business leaders, we should be making sure that our teams are running at scale with efficient solutions that the market has to offer. And AI has a place to play. AI has a role to play in those systems.
Awesome. Well, that's all we have the time for. So thank you
Hey,
so
Madison,
much.
thank you
Really
so much for your
appreciate it.
time.
Thank
Thank you.
you.